Hello geometry, here we go again. Lesson 3.5, our goal is to be able to prove two lines are parallel using angles created by transversals. By the end of this lesson, please be able to explain what these are: the converse of corresponding angle postulates, the converse of alternate interior angles theorem, the converse of consecutive interior angles theorem, and the converse of alternate exterior angles theorem. Recall what converse means. We talked about conditional statements a few weeks back where if P then Q. The converse is the opposite of that. If Q, then P. So, converse corresponding angles postulate, which we talked about just a couple days ago. If a transversal goes across two parallel lines, then the corresponding angles are congruent. So what would be the converse of this? Take a second, think about it. So here would be if P, the converse goes across two parallel lines, and the Q. So we're going to switch those ideas around. Converse of corresponding angles postulate. If corresponding angles are congruent, then the transversal goes across two parallel lines. We will use this idea of converse to prove two lines are parallel. So if you look at the difference, this one says if you have a transversal that goes across two parallel lines, then the angles are congruent. And this one says if the angles are congruent, then it must be going across two parallel lines. So this is how we're going to prove that lines are parallel. This is stuff that we've learned before. If a transversal cuts parallel lines, then the corresponding angles are congruent. If the transversal cuts parallel lines, then alternate interior angles are, what do you think? It's congruent. If transversal cuts parallel lines, then consecutive interior angles are, what's this one? It's the only one that's not congruent, supplementary. If transversal cuts parallel lines, then alternate exterior angles are congruent. So this is what we learned before. Now we're switching this around and doing the converse. If corresponding angles are congruent, then the transversal crosses parallel lines. If alternate interior angles are congruent, then the transversal crosses parallel lines. If consecutive interior angles are supplementary, then the transversal crosses parallel lines. If alternate exterior angles are congruent, then the transversal crosses parallel lines. Okay, so it's just the opposite of what we did before. In this picture, you've got this is 112 degrees and this is 112 degrees. We're talking about the converse of corresponding angle postulate. So do you think that lines A and B are parallel? Well, if corresponding angles are congruent, these are congruent, then that must mean they have to go, the transversal has to go across parallel lines. Lines A and B are parallel. You should put yes. Okay, because these are congruent, that means the lines must be parallel. Here's another example. What is the value of x so that R and S are parallel? Well, the only way R and S can be parallel is if these angles are congruent. These angles are, what kind of angles are they? Alternate interior, alternate exterior, corresponding, or consecutive interior? Well, in this case, hopefully you're realizing that these are alternate exterior. So alternate exterior angles need to be congruent. That means x has to be 110 degrees. So which postulated theorem do we use? We use the converse, not just a regular, but the converse of the alternate exterior angles theorem. Okay? Because we're proving the lines are parallel, so it's the converse. Same idea. What is the value of x so that R and S are parallel? Well, this angle and this angle right here are called, hopefully you know, they're called the consecutive interior angles. Okay, for consecutive interior, sorry about stopping this there. For consecutive interior, they have to be supplementary. So that means that x plus 110 should equal 180 degrees. But that means that x must be 70 degrees. So the value of x must be 70 degrees in order for R and S to be parallel. And we use the converse of consecutive interior angles theorem. Okay, theorem. What is the value of y so that R and S are parallel? Take a second and try to figure this one out. Okay, pause it if you need to. What kind of angles are these? This one and this one. Think to yourself, what are they? Hopefully you realize that they're alternate interior angles. So if they're alternate interior angles, they need to be congruent for this to be true. So we have to have y equaling 11y minus 50. These two things need to be equal to each other. So then we can figure out the value of y. So this is true. Subtract 11y. You get negative 10y equals negative 50. Divide by negative 10 there. You'll get y is 5. So the value of y needs to be 5. So I can put a 5 in here and a 5 in here. You'll see that these two things will be equal. So that these lines are parallel. We are using the converse. We're proving lines are parallel. So we're using the converse of alternate interior angles theorem. So your homework check will be for you to explain the difference between the regular postulates and theorems about transversals and also their converses. So blame, this is worded a little bit funny. I couldn't really think of a best way to word it, but you want to be able to explain the difference between the regular ones that we talked about and their converses. Basically, here's an example. An alternate exterior angles theorem says that if lines are parallel, then the angles are either congruent or supplementary depending on, well, I guess in this case alternate exterior, they're going to be congruent. If we were talking about consecutive interior, it would be supplementary. Then they are congruent. The converse of this is if you switch it around. If the angles are congruent, angles, let me just erase that. If the angles are congruent, then the lines are parallel. That's the parallel symbol. Here, let me just go ahead and write it out. Then the lines are parallel. Okay, so this is proving angles are congruent, and this one is proving that lines are parallel. Okay, try to remember those differences. Go back and watch the video again if you need to. Thanks for watching.